Good morning, student. You are watching You Will Love Math for beautiful mathematics content and beautiful mathematics learning with proper problem solving. So today you are all welcome in a new class, and in the today's class we will discuss about the proof of Pythagoras theorem. So you know the Pythagoras theorem, but the elegant proof of Pythagoras theorem using the similarity property is a gem of mathematics. Okay, so let's start the Pythagoras theorem. Okay, how to prove it? So let this is a right angle triangle where A is the right angle ABC. Okay, right angle at A. Fine. So you know the Pythagoras theorem is AB square plus AC square equals to BC square. Fine. You know that if this is right angle, opposite of right angle is hypotenuse. If this is height, or this may be base, or this may be base, this may be height, in terms of which angle you are observing, from which angle you are observing. A clear statement or clear learning is, if this is theta, okay, opposite of theta AB is base height or the perpendicular for the respect of theta, and AC is the base for theta. So for theta, AB is height, fine, and AC is base, fine. And if this is alpha, fine, if this is alpha, then for alpha, AC is height or perpendicular, and AB is base. So this is an information, or it is a very known information who have learned geometry in depth, not in depth, and trigonometry also, because it is the concept of sine theta cos theta which is taught basically in class 10 for the students who are learning trigonometry. This is also an important concept, which is height, which is base, and which line will be height and which line will be base, or which line segment will be height, which line segment will be base. Okay, so which side will be height and which side will be base. Now the thing is, we have to prove this statement or this theorem. So how can you do that? For that, one thing on information, you know all similarity, but let's recap. Okay, let's recap. Sorry, one pen I require. Okay, so if this is a triangle and this is a triangle, I am giving an example. You know, there is different toy shop where you can get a very small tiny car which is exactly looks alike a large car. Okay, so this is similar car. That means if this triangle, in this triangle, the side is different, but if the angle from, if this angle and this angle, this angle and this angle and this angle is equal to each other, then we can conclude that these two triangles are similar. Okay, if this is similar, then from the similarity property we can tell that opposite of the same valued angle, the side ratio will be equal to each other. What does it mean? That means if this is A, if this angle is A, pen is not working properly. If this is opposite of angle A is A, If this is opposite of angle, let it is PQR and it is ABC. So opposite of angle B is B, opposite of angle C is C, opposite of angle P is small p, opposite of Q is small q, opposite of R is small r. So from the similarity, what is the similar from the same valued angle? This and this. So opposite of same valued angle A by opposite of same valued angle P is exactly equal to C by R, B by Q. Fine. So this is the similarity property. This simple property will prove this elegant proof. Will prove this elegant proof. So now how can we do that? For that, we will drop a perpendicular. We will drop a perpendicular from A on BC. So it is AD. Fine. Now we are getting three triangles. This is a triangle ABD. This is a triangle ADC, and this is a right angle triangle ABC. So these three triangles are similar to each other. How can we prove that? Another thing, can anyone tell me, if I am telling that if in two triangles, if two angles are exactly equals to other, then the third angle will also be equal. How can we do that? It is very easy. Since the sum of the three angles of the triangle is 180, the sum of the two angle will be exactly equal to the sum of the other two angles. So if we subtract that value from the 180, the other value will be equal. Very easy. Like if this is this angle A, this angle P. So if we do that, if 180 minus angle A plus here B to B, B to Q. So B, what will we get from here? We will get from here C, and from here what will we get? 180 minus P minus Q. It will be exactly equal to R. So automatically C and R is equal. Okay. So for this, the two angles, if the two angles are equal, other one angle will also be equal for a triangle. Now these three triangles are similar. So how can we prove that? Let me prove it. Let me prove it first. Okay. So now you can see this is 90, this is 90. Let we have assumed this is alpha, this is theta. Good. So now for the large triangle ABC, this is alpha, this is theta. So theta plus alpha, how much? 90. So here again this angle plus alpha equals to 90. So this must be theta. And from here theta plus this angle equals to 90. So this must be alpha. Fine. For the two triangle, three angles are exactly equal, 90 90, alpha alpha, theta theta. Okay. So now from there we can get from ABD and from ADC, opposite of theta is BD. Fine. Opposite of theta is AD. Fine. Opposite of 90 AB. Fine. Opposite of 90 AC. Fine. Opposite of alpha AD. Fine. Opposite of alpha DC. Fine. For that it is done. Now these two triangles. In these two triangle, 90 90, alpha alpha, theta theta. So theta opposite of theta for the small angle. So from ABD and ABC. Fine. From ABD and ABC. Opposite of theta is BD. Opposite of theta is AB. opposite of alpha AD, opposite of alpha AC, opposite of 90 AB, opposite of 90 BC. Now from these two triangles, from triangle ADC and from triangle ABC, fine. So now alpha alpha theta theta 90 90, fine. So now opposite of theta is AD, opposite of theta is AB, opposite of alpha is opposite of alpha is CD, opposite of alpha is AC, opposite of 90 is AC, opposite of 90 is BC. Okay, so these three ratios or proportional value we have got. So now we will take where this will get a cross multiplication form. That means for that AD will be multiplied and BD and DC will be multiplied. So from here we can write AD square equals to BD into DC. From here we can write this through AB square equals to BC into BD. From these two we can write where AC AC. So AC square equals to BC into CD. Fine. Now one addition is remaining. The Pythagoras theorem, the elegant proof, the proof of the century is done. So how can we do that? We will add these two only. These two only. If it is equation 2 and this is equation 3. So now add AB square plus AC square. What we will get? BC into BD plus BC into CD. Take BC common. So what will we get? BD plus CD. That means BD plus CD. That means BC. So BC square. So we have proved AB square plus AC square equals to BC square. So the Pythagoras theorem is proved here. Okay. So a very beautiful, fundamental, elegant proof of mathematics, elegant proof of Euclidean geometry is proven here. Hope you have understood, hope you have learned a beautiful theorem, Pythagoras theorem. Thanks for watching. You will love math. Keep watching, keep tracking. You will love math for beautiful mathematics learning with proper problem solving. Thank you.